Okay, everyone, welcome to my channel. My name is Ryan Schul. I talk all about data analytics, predictive analytics, and machine learning, artificial intelligence, deep learning, data science, so on and so forth. So in the project today, I want to try to understand why do some projects fail and why do some projects succeed? And we're going to use a causal analysis approach to make this determination, okay? So causal inference or causal analysis, wait, there's two types, right? I did another video on this a little while back. There's actually two stages to this. There's causal discovery to see if there's actually a causal relationship, and if there is a relationship where one element affects another element, or one thing impacts another thing. That's the cause, and that's the effect. If there is some relationship there, then we can do a causal inference. So you can do a causal discovery and causal inference. I already know there's a causal discovery element here, so I'm just going to skip it right to the causal inference. So I was thinking about this recently, and the motivation for this project was basically, I was talking to a friend, and she said, "Oh, this project is delayed again, and it's failing, it's falling behind. I don't know why. I don't know what to do. It's very complex. There's a lot of moving parts." And these projects are always in delay. There are always some issue that comes up, and I don't know what it is. So I thought, why don't we use a statistical approach to try to determine what causes projects to fail and what causes projects to succeed? Okay, so that's what we're going to do here. So there's a few reasons why we might want to do this: to identify true root causes. What's the cause? What's the effect? Again, if there's an outcome, that's the effect. If something controls the outcome, that's the cause, right? So we're going to go beyond correlation. Correlation just tells us that things move together or they move apart. They could move similar or different from each other. This is beyond correlation, right? This is a cause and an effect, and we're going to look at both. So we can avoid false positives. We can simulate scenarios where, what if this happens? What if something happens? What's the effect on this? What if this other thing happens? What's the effect on that, right? So what if we hadn't been understaffed? What if the team had received extra training? What if the technology was up to speed where it should have been, right? If those things are positive, then the outcome should be positive. If all those things or any one of those things are lacking, then the outcome could be more obscure. You don't know what it's going to be, right? So support data-driven decision making, right? We always aim to do that. More funding, clearer goals, better stakeholder alignment, better technology, more focus on the resources that causally affect actions. That's the things we're going to look at. Enable policy optimization, and basically improve forecasting and manage risk better, right? We always want to keep an eye on risk management and try to predict if there's going to be a delay, and if there is, intercept it and account for that or manage that, right? And get things back on track. So I came up with this data frame right here. Control Enter to refresh. We have the project types: software development, infrastructure upgrade, marketing campaign, research initiative, and product launch. And possible causes of delays could be insufficient funding, lack of staff, scope creep. That's very important. That's a big one. I'll talk about that a little bit. Technical challenges, stakeholder delays, or none. Okay, there could be no delay, and the project is on track with where it should be. So we have a few variables here: the start date, duration, days, anticipated end date, duration, variation, actual end date, status, people involved, budget, cause, and corrective action. Okay, so we have increased budget, hire more staff, tighten scope, add experts, or improve communication if there is a corrective action required. Okay, so I just hit Control Enter to refresh this. This is what the data frame looks like. Okay, so we have the ID, start date, end date, total budget, people, projects, project goal, status, cause of delay, and suggested action. Okay, so looks good. Let us go ahead and create a data frame here. So this is basically just counting the number of items on track, slightly behind, or significantly behind. If we go over here, this is, what were we looking at? The status counts. Okay. Oh, status and the count. Okay. So looking at these statuses and the counts of each. So here's on track, slightly behind, on track, slightly behind, significantly behind, and on track. So we're just counting those. Okay. So that's the one significantly behind, and the others fall into these other buckets. So we can go ahead and label columns: the type of project, project goal, status, cause of delay, and suggested action. Okay. So similar to what we have over here. Project goal, status, cause of delay, and suggested action if there is indeed a delay. And we're going to go ahead and do like a basic machine learning exercise here and try to understand the, what are we doing here? The classification, class names, feature importance. Okay, so this one is feature importance. So we're looking at which features are driving which features are having an impact on the target variables. So these are the independent features. If you've looked at any of my other machine learning videos, you see I talk about this all the time. Independent features can have an impact on the target. The dependent feature, this is independent. So this was going to be whatever it's going to be, right? But the dependent feature should be dependent on the independent variables. Okay, so independent variables, dependent variable, you always have one dependent, and you can have one, or more likely, if it's just a basic linear relationship, you'll have multiple independent variables. Here we have 4, and we're going to see what kind of statistical impact it has on the target variable, which is status, which is the delay of the project, or is it on time, right? That's what we're looking at. So we can look at the features over here. So the suggested action, Control Enter to refresh just to make sure I got this one. So suggested action is cause of delay. So 37% of the time that is going to cause the status to become delayed, right? If we have a delay, then there's going to be a delay. That's a cause and effect. That's not brain surgery there, right? That's pretty obvious. And the suggested action 45% of the time is going to have an impact on the status, causing the project to be delayed. So if we look at this again, these two categories are the main ones. This is 10%. This is only 6.9, about 7%. Project goal type of project does have an influence on the target variable, which is the status of the project becoming late or not late, or delayed, whatever you want to call it. Suggested action and cause of delay, that's what we're looking over here. So suggested action over here has a 45% influence on the target variable, and cause of delay has about 35%. So I think, what is that, like 80% total? 45 and 37. So a little bit, what is that? 4, 3, 7, 10, 87%, about 87% of the time. Most of the time, the cause of the influence, the cause of the status of the project to be delayed is driven by suggested action or cause of delay, right? So we know that feature importance is telling us that cause of delay, suggested action is driving the status about 87% of the time. And now this is what the classification report is telling us. This is a feature importance. This is the classification report. So we can see the precision, recall, F1 score, and support are all 1.0. So this is perfect. Basically, on track, precision 1.0. This models the predicted on track with perfect accuracy. The recall, it caught all actual on track cases. Okay, again, perfect classification report here. F1 score 1.0, again, perfect balance of precision and recall. And the support is basically also on track. And we have 3.0 for that. Okay, so again, perfect report. But again, like, I'm not going for like the perfect classifier to be able to predict all kinds of unknowns. This data set is pretty small. It's only 30 rows with 11 columns. So essentially, like, the ML algorithm is going to see a few different scenarios and try to predict and anticipate what's going to happen next. And it does that with perfect accuracy. We see 1.0. In the real world, we probably have a much bigger scaled out, scoped up report. So these numbers would probably be slightly lower. But again, I would expect it to be pretty much on par with this report right here. It's like almost too good to be true, but the goal of this video is not to dial in the precision of the classification report. It's to look at the causal analysis of why projects become delayed or why they finish on time, right? So this is a visual representation of what we just saw. The suggested action is 45%, has 45% influence on the status becoming either delayed or on time for the project, and this is 37%. So combined, that is 82, I think 82% coverage. This is another 10, so 92, and 7 from that. So it's almost 100% coverage right there. So most of it comes from suggested action and cause of delay. So this is the where everything happens. This is where the magic happens right here. So the DoWhy library is coming from causal model, right? So again, we're looking at the cause and effect. What is causing this project to be delayed? or to not be delayed. That's what I'm trying to understand. So we did some data science work over here to understand the setup, to understand the data and like how the data is coming to us and what it all means. Now we're going to jump in with both feet. Okay. We're going all in to understand the DoWhy library and the causal model. So we have the data frame, the treatment is binary here, causal delay is going to be encoded. So anything that is not a number, we have to encode as a numerical representation of that number. So project ID, I don't care about. An ID is ID. It doesn't tell us anything, right? Start date and anticipated end dates could be important. They're not necessarily important all the time. It really depends what you're doing. Total budget is a number. This people involved is a number. So that's important. What the label encoder is going to do is convert research initiative, product launch, research initiative, goal 1, 2, 3, on track, none, stakeholder delays, improved communication. Anything that's not a number, so anything that's not total budget or people involved, all these 5 columns, these 5 columns have to be label encoded for the machine to be able to understand what's going on. It doesn't know delay, on time, scope creep. It doesn't know what any of these things are. We have to take this data, encode it in a representation that is numerical so the model can go ahead and understand it and then feed that into the model. So we have data. DF is encoded right here. So here's the encoded model. Okay. I'm taking the data frame.copy so I don't mess around with the original data frame and do all the work on the encoded model right here. So it's always good practice. You can use the same data frame if you want. You can have data frame over here and encode that. I like to take a copy of this. Then if I have to go back a couple of steps, this is unchanged, right? Like when I'm doing my manipulation on this right here. So that is what is going to be updated and manufactured and manipulated. This is not going to be manipulated. So if I have to go back a couple of steps, I only have to go back here. I don't have to go back all the way to the beginning and rerun the whole analysis from the beginning, right? So it's always good practice just to take a copy of the data frame and work with a copy. So that's what I'm going to say about that. So here's the encoded columns and the encoding, the label encoder fit transform is doing all the magic right here. So we have the treatment binary, DF encoded status coming into treatment and outcome. So there's encoding, if encoding treatment less than 2, continue. Then we have the encoded representation of that data frame that I just showed you fed into data. And the treatment is going to be the treatment and the outcome is the outcome. Okay, so the treatment comes from here. The F encoded number of classes that are unique and the outcome comes from the status. So remember, that is the dependent variable. Remember, these are the independent variables. So this could be anything, right? This can be anything in the world. But what of these anythings affect the status of the project to cause it to be delayed or not delayed? That's what I'm trying to determine. So you have your treatment. These are independent variables. The outcome is a dependent. You could think of it like that. This is the data frame that's encoded. And the causal model is going to do the whole lift for us, okay? So the cause of delay is represented by this variable right here, cause, and the estimated effect is estimate.value. So if I go ahead and run this, Control Enter, just to make sure I ran it. I can't remember if I ran it or not. I think I did. So I have the causal model right here. Sorry, DF encoded, treatment, outcome, and then common clauses. That comes from the original data frame. Again, this is label encoded data, so it's a little bit different now, but we have the type of project goal, and suggested action, which matches this over here. Okay, suggested action, project goal, type of project, and we're trying to predict that status as either delayed or not delayed. So hopefully this makes sense. When you hit Control Enter to run the cell, you get the output down here. Cause of delay, scope creep, estimated effect 1.3, stakeholder delay 1.3, insufficient funding 1.3, technical challenges 1.2, lack of staff 1.1, and none means there's no delay. The project's on track. It's actually negative. To tell you the truth, I don't know what negative means in this case, but it's a non-issue, right? There's no impact. I guess just negative means it's fine. Maybe there's a scale that it goes down to -2 or something. But if there's no cause of delay, the project is intact. It's on track to be completed on time, and there's no delay, right? So pretty obvious what's happening there. So, but this is very interesting too. So all this code over here in this one cell in Jupyter Notebook does the lift, and it does some pretty interesting things, right? It reports 1.3 estimated effect. So that's the value of the fact that it's not really a percent. It's really like a real number. It's not a percentage or anything like that. But most of the problems from the delays of projects come from scope creep. So what is scope creep? I've dealt with this before when I worked in the consulting business, Google scope creep. Basically, it's when the definition of the project or the contract that you sign when you're going to do a statement of work, it's called a SOW, abbreviated SOW, statement of work. um, Everything is defined in the SOW, right? And this whole scope is everything that you plan to do as a consulting team. When you go into this enterprise that you're working with, everything you're going to do is the scope of the project. But sometimes you get into situations where the project expands and the scope kind of creeps outwards because you're adding in more layers and more stuff. And now you're going to do what you originally intended to do, but now you have to do a couple more things. You have to add in a couple more things over here, and then you're going to bake in a couple extra things at the end. That's scope creep, and that is going to delay your project, right? If you sign a contract to perform your statement of work, right, and you have the scope and that's defined, that's a contractual obligation. You have to commit to that, right? You don't manipulate the contract after it's signed. That's a designated signed contract that you adhere to, right? So the person that's paying you is paying you based on the outcome of the contract. You have to perform according to the details or the description of that contract. You don't change the contract as you go. If you do that, you're going to have scope creep and you're going to have a delayed project, okay? That's guaranteed. Stakeholder delays. This essentially is the stakeholder maybe changing their mind. Maybe they're giving you scope creep. Maybe the stakeholder says, well, I want to add in a couple more things, or, I'm going to be on vacation. I can't sign off on this, or I'm going to be out of town. I'm traveling for work. I can't do this. If the stakeholder is holding you up, then potentially the whole project is going to be delayed, right? So you want to avoid that. Avoid scope creep, avoid stakeholder delays, be efficient, interact with the customer, communicate with them, tell them what's going on, but don't cause a lot of delays and don't let them cause delays for you. Insufficient funding, right? If you can't hire enough people, that's the next thing right here. Lack of staff and insufficient funding, these things go hand in hand. If you don't have enough funding up front, then you can't complete the project on time. There's going to be delays. There's going to be project delays, right? And then we see this right here. The DoWhy project library, or the DoWhy library, is telling us, does X cause Y? What would Y have been if X were different? If there was no scope creep, the project would be on time. If there was no stakeholder delays, project would be on time. If there was sufficient funding, project would be on time. Insufficient funding, I don't know. It's going off track. It's going into a ditch. Technical challenges, if there's technical challenges. Now, this one, I think this is legitimate if there's some technical challenge that you didn't anticipate first. Now, you probably shouldn't have as part of your due diligence, but something comes up and it's just not working out the way you expected. There could be technical challenges and that could take your project off track, right? I understand that one. Probably shouldn't happen. You should probably do the due diligence, anticipate this up front. If you legitimately have some weird thing that just comes up at the end or midway through the project, nobody can anticipate that. Okay, I'll give you that. Like, these things happen. It's called life, right? Life is unpredictable, but you should try to prevent these. So that one, I would say that is kind of okay because you can't anticipate every single potential outcome of everything. That could delay your project. But these other things are not okay, right? Don't allow that. Don't allow that. Don't allow that. And don't allow that. If you need more staff, get the staff. I've worked on projects where we were understaffed. We got staff immediately. It's like we were falling behind. Get these people on this project on point so we can deliver on time, right? So I've seen that happen. But you have to manage this whole process, right? And anticipate what's going to happen and try to prevent that from happening. Okay, so I have some notes over here. Causal models, specifications of part of the DoWhy library, the treatment, whether a specific delay causes a certain outcome. The outcome is the status of the project. Is it on time or is it delayed? There's basically just two things. It's a binary, right? Common causes, other project-related variables. We just saw that. I'm not going to address that anymore. I think we beat that horse to death. Used propensity score matching, great for binary treatment. Sorted causal effects, allows ranking and root cause analysis, right, based on the impact of the delay of the project. Interpreted the results for a specific cause. lack of staff. That's exactly what we did over here. Okay. So now if your project is falling behind, you can use this analysis, this kind of like causal analysis to determine what is the cause and what's the effect. The effect is a delayed project. Is it scope creep? Yes. 1.3 is the weight or the factor assigned to scope creep. Stakeholder delay, 1.3. Insufficient funding, 1.3. Technical challenges. Again, this one is kind of fungible, I think. You can't anticipate every single thing that's going to happen. I would say if technical challenges come up, then you deal with it, but you can't like anticipate every single thing at the start of the project. Lack of staff, there's no excuse for that. If you are understaffed or underfunded, get more funding, get more staff, get it done. Okay. One more plot here. I think this is just a plot of what we saw before. Yeah, scope creep. So 1.37. These are the metrics that have been assigned. 1.2 for lack of staff. That's the estimated effect. Okay, it's called estimated effect. 1.37 and 1.2, and the estimated effect for no delay is none. Again, I don't know what the -2 means, but if there's no delay, like who cares? Who cares if it's negative? These are positive factors that will impact the project being delayed. If it's negative, I would have to look into that. I'm not exactly sure what that means, but it's a non-issue. It's a no issue here. Okay. So in conclusion here, causal inference is about understanding leverage points. What actions can you take that actually literally make a difference in the outcome of the status of the project? Is it going to be delivered on time or is it going to be delayed? Okay. There's only two outcomes here. And in the context of project performance, it's your key to shifting from reactive triage. You don't want to be doing reactive triage, right? To proactive management and prevention from all of this nonsense coming up in the beginning, right? So you don't want reactive triage, you want proactive preventative maintenance. Okay, that's the goal here. So if you can achieve that goal, congratulations, pat yourself on the back. That's a win. Okay, so that's it, guys. Causal analysis. Hopefully, that was insightful and meaningful and practical for you guys. I'd like to do these types of things. If you see something or have some idea that I haven't discussed yet, I've got like about 340 videos on my channel at this point. So I've talked about a lot of different topics, a lot of stuff going on here. But if you see something that I haven't discussed or you think of something I haven't talked about, let me know. I can try to do that. I had several suggestions and I tried to address those. I didn't get to every single one. There's one or two, didn't really even know what the comments really meant. So I can't do it. If I can't understand that, I can't do it. But there was a few comments that came in and it was clear as the light of day, and I did those. So if you have some suggestions, go ahead and make those suggestions. Go ahead and subscribe if you haven't done so. And please watch the video from beginning to end to get the full effect so you know how everything works. And it also helps my stats and my timing too. I'm trying to promote this channel and get monetized at some point. I've been doing this for almost 1 calendar year and haven't made a penny on this thing so far. Hopefully soon, but who knows? Who knows what's going on here? So that's it. I'm going to wrap it up here. I just saved the file. I will upload the all the sample code, so you have all the sample code. You can copy and paste it and run this for yourself in your own Jupyter notebook and get the outcome that I see here. And then by all means, change the inputs. Go ahead and change the data frame over here. Here's my data frame. I just made this up with synthetic data. Put in your own project, right? And try to analyze your own project and see if this is on track, what's the status of the project, or if it's falling behind, what is causing it to fall behind. This is a whole cause and effect. If something happens, what is the outcome of that, right? If there's a trigger, what's the effect? If there's a cause, what's the effect? That's the whole point of doing this exercise, okay? So yeah, hopefully that hit home and help to clarify causal analysis. If you didn't know what that is, hopefully now you know what it is. And that's it, guys. I'm going to wrap it up here. I'll post the code and I'll post a video a little bit later today. And we'll see you in the next one. Goodbye for now.